Okay, today we're going to go ahead and get into section 1.4. All right. This time we're going to be looking at measuring and constructing angles. So we're going to be looking at what is an angle. So our goal is to identify angles and angle bisectors and congruent angles. So first, let's talk about an angle. An angle is made up of two rays with a common endpoint called the vertex. So this point that they share is called the vertex. And we have a ray and a ray. All right. So we're going to look at four ways to name this angle right here. All right. The best way to name an angle is to use three letters. All right. And when we use the three letters, we want to make sure the angle or the letter by the angle is in the middle. So for example, if I go to name this angle right here in three ways, if I start at an N, I notice that angle Q is in the middle. So I want to go P to Q to R. So I'm going to use an angle symbol, and I'm going to go P to Q to R. All right, notice the angle is by Q. Q is my letter in the middle. Now, if I went PQR, I could have done the reverse. I could have done R, Q, P. All right. Now, again, Q has to be in the middle because that's where the angle is. Now, occasionally they'll put a number in there by the angle. So we could call this angle 1, all right? So those are the best three ways to call it. Because there's only one angle in this picture, we could also call this angle Q. But I'm going to tell you to try to stay away from one letter because when these pictures start to have multiple angles, we can no longer just use one letter. So option 1 and 2 are the best. Use three letters. If they give us a number in there, then we can try to go ahead and use that, all right? But try to use three letters. That's the best way. We're going to go ahead and use the second one. We're going to use three letters to name it first because that's the best way to name the angle. All right, if I go to name this angle, notice the angle is by J, so I want J to be in the middle. So I can call this angle HJK. All right, H to J to K. If I trace it, it should be the opening. Remember, I could flip that, so I could go KJH. All right, and then I could also call this angle J, but again, the top two are the best two to go with. We want to use three letters when we go to label angles because these pictures are going to start to get a little more hectic. Okay, let's look at example 3 here. They want us to go ahead and name three different angles in this picture. So I see three angles. The first angle I'm going to name is this angle right here. All right, so I trace the opening. It's making sort of like this alligator opening. The three letters on that are DBA or ABD. Notice the angle is by B, so it has to be in the middle. So I'm going to call the first angle ABD. All right, now we're going to look at this picture and try to find another angle. Well, I notice there's another angle right here next to it. All right, notice it's opening like an alligator with my hand. The angle is by B. The letters could be CBD or DBC. So I'm going to call it angle CBD. B has to be in the middle of that angle because that is the opening part of it. Now, they want us to name one other angle in this picture. Well, there's one big angle in this picture, the two of them combined. All right, so the letters on this could be ABC or CBA. Again, B has to be in the middle because that's where the angle is taking place. I'm going to call it angle ABC. So we've named all three angles in this picture. So to name an angle, we need the vertex in the middle. The letter in the middle has to be where the opening is, and we need to use three letters as the best way to name an angle. All right. Now, let's go move on to the next part, and let's classify angles based on their measurement. All right, so our first word is acute. Acute angle. No, just kidding. Acute. Acute means that it is less than 90 degrees. It's less than 90 degrees. All right, so acute means less than 90. A right angle is our next word. Right means that it equals 90 degrees. Now, how do we know that it equals 90 degrees? They will put this little symbol, this box, little square box in the corner to show that it stands for 90 degrees. So if you ever see a little square box by the angle, it means that it's 90 degrees. Obtuse is our third types of angles. Okay, those types of angles are angles that are more than 90. Okay, they're more than 90, and they're less than 180. So they're somewhere, think 90 to 180. Can't equal 90, it can't equal 180, it's got to be somewhere in between it. The last type of angle is a straight line, or what we call a straight angle. All right, a straight angle or a straight line will always add up to equal 180 degrees exact. So how do we just look at a picture and tell if it's acute, right, obtuse, or straight? So here's the deal. What we do is we use the right angle to tell. The right angle forms like a perfect L. All right. If the angle's smaller than that, then it's acute. If it opens up bigger than our 90, then it's right. Or it's obtuse, excuse me. If it's bigger than it's 90, then it's obtuse. And if it equals 90, then we call it a right angle. So let's do some examples. First one says angle NMP. So let's go ahead and trace it. I'm going to start at N, I'm going to go to M, I'm going to go to P. Right now I'm going to visually look at that, and I'm going to try to look at it and compare it to the L. Is what I just traced, is that open up bigger or smaller than the L? Well, in this case, it opens up way bigger than an L, so I'm going to call this obtuse. All right, again, we're going to use this L to try to check what it is. All right, second one says QMN. QMN. So again, I always like to trace it. It helps me see it. So let's go ahead and trace, start at Q, go to M, and then go to N. Ooh, notice we traced a perfect L, so we're going to call that a right angle. It equals 90 degrees. All right, let's go to our third one. It says PMQ, so I'm going to start at P, go to M, go to Q. Notice it's like a little V. It's smaller than our L shape that we use to judge it on based on 90. It's smaller. Smaller means that it would be acute. All right, so we're going to use the 90-degree angle to go ahead and decide whether it's acute, right, obtuse, or straight. Now, to measure an angle, we can use what we call a protractor. All right, in this picture, we notice the DEG is acute. All right, so I know that DEG has to be less than 180, or less than 90, excuse me, less than 90. All right, now, because it's less than 90, when I read this, I want to read this line where it goes, and I want to take the number that's smaller than 90. So you'll notice this hits at 125 and 55. Because I know this angle is smaller than 90, I have to go and use the 55-degree mark from our protractor. All right, let's look at what happens if they gave us a different angle. Let's say they gave us angle GEF, so let's trace it. G to E to F is this opening right here, and you'll notice that is an obtuse angle. It's got to be bigger than 90 degrees. Well, I see two numbers that it went through here. I see a 125 and a 55. All right, you'll notice that it's obtuse, so I need the number that's bigger than 90, so I'm going to choose the 125 degrees. All right, protractor is just a tool you can use to measure. We don't use it very much in this class. However, we want to make sure that you see it. Okay, let's keep moving. All right. Now, what we are going to be doing in this is just like we did last sections, we did segment addition. Today we're going to be doing different things with angle addition. All right, so if I wanted to find the total of this whole big angle, I can go ahead and add them together to get my answer. All right, so if I want to find the whole big angle here, I would be taking 48 plus 48 which tells me the whole big angle is 96 degrees. Now, if angles are equal, what they'll use is what we call curls, or little arc marks, to show that they're congruent. So they might put a curl here and a curl here. All right, that just shows that the two angles are congruent angles. They're the same measurement. All right. Okay, one other key vocab word, angle bisector. Remember from segment bisector, when we see the word bisector, we want to think equal. All right, so an angle bisector is going to split it into two equal angles. So in this picture, VW is an angle bisector. It splits it into two equal angles. All right, so what we're going to do is we're going to try to fill in angles and look for straight lines. Remember, straight lines add up to 180. All right, let's go look. It says find each angle measurement from the picture. All right, there we go. Now, straight lines have to add up to 180 in these pictures. So, find the measure of CFB if AFC, so they want us to find CFB. So let's look where CFB is. C to F to B is this angle right here, where my dot is. All right, what I notice in this picture is that this line right here is a straight line. And straight lines have to add up to 180. So my pink dot and this 78 have to add up to 180. So if I do 180 minus 78, it will tell me my answer for my pink dot, which tells me an angle of 102. All right, so what we do is we look for straight lines, and straight lines have to add up to 180. All right, you'll notice we use those right there, and we got 102. Now, the next question asks us to find EFA. So let's trace E to F to A. We're looking for this purple dot, okay? Now, what we have to do is we have to look for straight lines. You'll notice in this picture, this right here is a straight line. So everything above it has to add up to 180. I have 51, 78, and blank. So to find this purple dot, the blank part, I can take 180 minus 78 minus 51, and that'll tell me what's left above, because all straight lines have to add up to 180. Well, 180 minus 78 minus 51 is going to give you 51. So we can fill it into our picture now. So our angle was 51. We could have found that based on this being congruent also. It says that it's congruent to the other angle. However, I want to show that straight lines have to add up to 180. All right, here we go. Find angle EFC if DFC is equal to AFB. Well, let's figure this out. It says that DFC is equal to AFB. So let's look at our picture. It says in our picture that AFB is 78. Well, if DFC is the same, DFC is 78 right here. Now it wants us to find the measurement of angle EFC. So we have all our numbers filled in. Let's trace EFC and see what numbers are inside it. So if I go to my picture and I start at E, I go to F, I go to C. I notice there's two numbers in here. There's 51 and 78. If I add 51 plus 78 to find that whole entire angle, I get 129 degrees. All right. Again, it's a lot of tracing and a lot of filling in. All right, let's go to the last question, see what they ask us. Find measure EFA if DFA is a right angle. So they're telling us that DFA is a right angle for this question. Okay? They want us to find EFA. So if I go E to F to A, that's this little piece here. Well, if they tell us that is 90, that means those two angles have to add up to 90. Well, if one angle's 51, then 90 minus 51 will tell us what's left. Well, if you do 90 minus 51, you're going to see that you get 39 degrees. All right, so we use the same picture to answer a lot right there, which can get a little bit confusing. But we will go ahead and try to show you in a picture. All right, let's look at a picture and try to solve some now. It says we have T in the interior, so T is the inside point. We have PQR, angle PQR, so PQ has to be down by the angle and R down on the side. It says that PQR equals 25. So if I trace PQR, I notice that P to Q to R is the whole thing. So the whole thing has to add up to equal 25. The second bit of information here tells us that RQT is 11. So if I trace R to Q to T, this little opening is 11. They want us to find the missing angle, so I'm going to call it X. All right, angle addition says the first angle, X, plus the second angle, 11, has to equal the whole big angle, which they told us was 25. If I subtract 11 from both sides, it tells me that X would have had to have been 14 degrees. So the missing angle in this would have had to have been 14. All right, so that's our angle addition. Angle part 1 plus angle part 2 equals whole big angle that they gave us. All right, question 14. I see a key word here. QT bisects angle PQR. Bisects. The second we want to think equal when we see the word bisects. Now it says angle PQR, so I got P, Q, and R points on it. Okay, it says QT is the bisector, so QT is the line that splits it. Now before I do anything, I'm going to label little curls here to show that they're equal, because I know the word bisect splits them into equal parts. Now let's go ahead and solve it. PQR is 104, so let's trace it. PQR, so they're telling us the whole big thing equals 104. Now, it wants us to find these other two angles. Well, we know these two angles are equal. All right, if they're equal, then these two angles should be the same measurement, and it should be whatever 504 is, or 104 is, split in half. So what I could do is I could put an X here and an X here, and I could say X plus X equals 104. Well, that's 2 X's equals 104. Divide by 2, and I get X to equal 52, which makes sense. They would both be 52. They're both the same. If you saw this right away and you said bisects, I know it's equal, you could have just taken 104 and cut it in half, and you would have gotten 52 right away. But again, I'm showing you with an equation so you can see how to set it up. All right, let's go ahead and try 2 more and see how you do. Let's show 2 other ways that we can do this and show you how you'd have to solve it algebraically this time. All right, number 15. T is in the interior of angle PQR. So PQR, T is on the interior. So we have our labels. Now let's label our picture correctly. So the first one says 12x plus 4 for PQR. So P to Q to R, we're talking about the whole big angle. So the whole thing should equal 12x plus 4. The next one says RQT. So if I trace R to Q to T, I'm talking about this opening right here, 3x plus 16. The last thing they give us is PQT. So if I trace P to Q to T, I have 7x minus 6 here. All right, so my equation's going to be the first angle, the left angle, plus the angle on the right equals the whole big angle. All right, so we're going to do angle addition here. So I'm going to start off with the first equation in the first angle, 7x minus 6, plus my other angle is 3x plus 16. That should be equal to the whole entire big angle, 12x plus 4. Now, just like we did when we had segment addition, we had to combine like terms first and clean it up. So 7x plus 3x is 10x. Negative 6 plus 16 is positive 10, and that should be equal to 12x plus 4. I'm going to subtract 12x from both sides. I'm left with negative 2x plus 10 equals 4. I'm going to subtract 10. I'm left with negative 2x equals negative 6. Divide by negative 2, and I get x to equal 3. Now, the question says, determine PQT. So we have to decide, do I have to plug it into one part, all parts, both parts, etc.? Well, if I trace PQT, you'll notice it's this equation right here. So to find that angle, we're going to go back and plug it in. So let's plug it in. 7 times 3 minus 6. 7 times 3 is 21. 21 minus 6 tells me the angle is 15 degrees. All right, so the angle 1 plus angle 2 equals the whole entire angle. All right, let's go to our last one. All right, if QT bisects angle PQR, so PQR is our angle, QT bisects it. So right away I know equal, equal. All right, let's label our picture. The first one says PQR. So PQR, the whole angle is 5x minus 6. The second thing they tell us is RQT. So R to Q to T is 2x plus 1. Now, this is similar to our midpoint question we had. We have two equal angles here, but I have an equation in one of the angles, and then I have an equation for the whole entire big picture. I cannot take one little angle and set it equal to both angles, the big picture combined. So what happens is, because these are equal parts, if this is 2x plus 1, I can put 2x plus 1 inside here. And now we can take angle 1, 2x plus 1, plus angle 2, 2x plus 1, equals whole big angle. Well, combine like terms and clean it up before we solve. So 2x plus 2x is 4x. 1 plus 1 is 2, and that should be equal to 5x minus 6. If I solve this, I'll subtract 5x from both sides. I'm left with negative 1x plus 2 equals negative 6. I'll subtract 2 over, and I get negative 1x equals negative 8. I'll divide by negative 1, which will tell me x equals 8. Now, the question asks us to find PQT and RQT. So, if I trace PQT, you'll notice it's the equation 2x plus 1. So I'm going to do 2 times 8 plus 1. 16 plus 1 tells me 17, so angle P, QT, equals 17 degrees. Well, it wants me to find RQT. Well, I know these should be the same, but I'll plug it in just to make sure. If I trace RQT, the equation 2x plus 1 was there. Well, 16 plus 1 tells me that angle RQT equals 17 also. Well, if they're both 17, then the whole entire thing would equal 34 by taking 17 plus 17. So, two things from angle addition today. We can take left angle plus right angle and set it equal to whole entire big angle. If it says bisects, then we need to mark two equal angles in our picture and then label it. All right, this is angle addition and angle bisector. We will now do some practice and reteach it. Keep up the great work, kids.